So today I want to pick up on something that we talked about in the last video, which was the area enclosed by squares and rectangles. And last time we saw that if you take a square and you compare it to a rectangle that has the same perimeter, so for example a 5 by 5 square which has a perimeter of 20 versus a 3 by 7 rectangle, we saw in the last video that the area of the square was more than the area of the corresponding rectangle when you keep the perimeter fixed. And what I want to do in this video is show you that even though the square comes out on top among rectangles, that it doesn't come out on top when we compare it to other shapes, and in particular, if you take a circle and a square with the same perimeter, then the circle has a higher area than the square. That's what we're going to show today. So the perimeter of a circle, which is something which is also called its circumference, is equal to 2 pi r, where r is the radius of the circle. And meanwhile, the perimeter of a square is of course equal to 4s, where s is the side length of the square, 1, 2, 3, 4. So we have a formula for the perimeter of a circle, or it's just the circumference of a circle, same thing, and a formula for the perimeter of a square. So let's say the perimeter is p. So we have a fixed perimeter, like a fixed length of a gate or something, a fence that we're using to enclose an area, and we can either arrange it in a circle, right, or we can arrange it in a square. So in the case of a circle, we know that p equals 2 pi r. We've used the perimeter that we have, this length p that we have, to make a circle. And so that implies that, I'll draw it over here, that implies that the radius of the circle must be p divided by 2 pi. And in the case of a square, we have that p equals 4s. We've used the same length of fence or whatever to enclose a square area, and that means that the side length of the square must be p divided by 4. Now we can calculate the areas of these two figures, because the area of the square is of course equal to s squared, the side length times the side length, which is equal to p squared over 16. By the way, if you look at the last video, we calculated the area of an arbitrary rectangle any dimension of any dimensions where the perimeter adds up to some fixed value. And if you apply that formula we found to the case where it's actually a square, you get p squared over 16. So that part checks out. And now we can compare that versus the area of a circle, which we use the formula pi r squared, and our value for r here is p over 2 pi, so this is pi times p squared over 2 pi squared, which is 4 pi squared, which gives us, if I cancel this pi with one of these pi's, p squared divided by 4 pi. So I've got the area of my square and the area of my circle, both of which were created to have the same perimeter of p. Which one's bigger? Well, pi is, we don't need to know exactly what pi is. All we really need to know is, I'll write it over here, pi is less than 4. It's 3.1415 blah blah blah. But it's less than 4. And that's really all I need to complete this proof, because if pi is less than 4, then 4 pi is less than 16. Which means here, to get the area of the square, we're dividing the square of the perimeter by 16. And here, to get the area of the circle, we're dividing the same number, the perimeter squared, by something less than 16. And if we're dividing it by something less than 16, it means that this number here must be bigger, than this number here. Because the denominator is smaller, we're not dividing it by as much. And that just follows again from the fact that pi is less than 4. So we've shown what we wanted to show, which is that a circle encloses more area than a square with the same perimeter.